Hamathon Achai. Ahanoston Net. The power of the enemy is growing.
If the power of the enemy is growing, then we can infer A. The growth rate of Sauron's power is positive, because if the power is growing, that means the power is increasing, thus the rate is positive. Legolas is sliding down the stairs of Helm's Deep on a plank at an initial rate of 6 centimeters per second. His acceleration is modeled by the function a of t equals 0.9t minus 20, for when t is between 0 and 22, or equal to. If he slides for 10 seconds, how far has he traveled down the stairs? By integrating a of t and using the initial velocity of 6 centimeters per second, we get 791.808 centimeters. If the trajectory of the arrows Legolas shoots is modeled by the function s of t equals negative 0.05x squared plus 0.3x plus 4.55, how long will it take for the arrows that miss his targets to hit the ground? We can solve this by setting s of t equal to 0 and getting t equals 13 seconds.
In the land of Mordor, in the fires of Mount Doom, the Dark Lord Sauron forged in secret a Master Ring to control all others.
Mount Doom's lava has a temperature of 950 degrees, and the One Ring was 900 degrees after 5 minutes in the cast when it was forged. How long did it take the ring to cool down to 30 degrees at room temperature, or 25 degrees Celsius, if it started at the same temperature as the lava? We can use Newton's cooling law to model heat transfer of objects with the differential equation. The change in temperature over the change in time equals k times t minus a, where k and a are proportionality constant and the ambient temperature respectively. We solve the differential equation by separating the variables and integrating both sides, and we thus get the temperature equals a plus the second constant times e to the kt. We find the particular solution, then, by using t of 0 equals 950, and we get the second constant equals 925. Then we can solve for k, and we get approximately negative 0.011. Thus, we have the function for temperature in regards to time. Then, to solve for time, we set t of t equals 30, and we get time equals 469.71 minutes, or 7.83 hours.
Undone.
Arise, riders of Theoden! Spears shall be shaken! Shields shall be splintered! A sword day! A red day! And the sun rises!
During the Battle of the Pelennor Fields in the Third Age, the Rohirrim of Rohan charged at the Orc army with a velocity modeled by the function r of t equals t cubed plus 2t squared plus 3.2t plus 5. The Rohirrim are initially at rest as Theoden makes his final battle speech. If the Orc army is stationary and positioned 300 meters away from the Rohirrim initially, at what time will the Rohirrim reach the Orc army after they begin charging at this velocity? What is the Rohirrim's velocity at this time? Assume that all riders of the Rohirrim travel at a uniform speed. We integrate r of t and solve for x, getting x equals 4.976. We then find the velocity at this time. So r of x is 193.699, which is the velocity of the Rohirrim at this time. One of the orcs shoots an arrow at an angle from the ground during the charge of the Rohirrim. The position function of the arrow is modeled by the parametric equations x of t equals 3.5t and y of t equals 0.4 plus 2.7t minus 4.9t squared. Please find the horizontal distance of the arrow's trajectory. By setting y of t equal to 0, we get t equals 0.672. At this time, x is equal to 2.352, which gives us the horizontal distance of the arrow's trajectory. Please find the arrow's maximum vertical displacement from the flat ground. We find the time when y prime of t equals 0. We get t equals 0.27551. We plug in t into x of t. We get x equals 0.9643 meters. Please find the total distance covered by the arrow. By setting y of t equal to 0, we can find the time that this lands. We get t equals 0.672. Then we evaluate the arc length integral from t equals 0 to t equals 0.672. And we use the arc length equation, we get 2.68997, which is the total distance covered by the arrow during this time.
You know this. Umathon.